All right, guys, we are practicing with effects of changing dimensions. So this means if I have some sort of 3D figure, I am changing the dimensions of the figure. That means I'm either changing the length or the width or the height or the lateral height or something like that. So in this case, this is a case where all of the dimensions change at the same time. Okay, if all the dimensions change at the same time, the factor by which we're changing the dimensions, if that scale factor is a, let's say we're making everything a times bigger, a times smaller, then the surface area will change by a squared, and the volume will change by a cubed. So if I'm doubling everything, that means I'm multiplying my figure by a scale factor of 2. That means 2 is my a. Then the surface area of that figure will grow with a squared, or 2 squared, which will be 2 times 2, which equals 4. So that means that the surface area will grow 4 times as big, and then the volume will grow 2 to the third times as big, which is 2 times 2 times 2, so that's 8. So it'll grow 8 times as big. So that is kind of my pattern. So I have a word problem here. It says the surface area of a figure is 736 inches squared. That's the surface area, okay? That's important. If the dimensions are multiplied by a fourth, so this is just the dimensions, not the surface area, the actual dimensions. So I'm looking at my scale factor here being 1/4. What will be the surface area of the new figure? And I want to know the new surface area. Okay, so if the scale factor is 1/4, I want to find what I need to multiply the surface area by to get my new surface area. So if the relationship is 1/4 and the surface area will be a squared as big, I'm going to try multiplying that, my 1/4. I'm plugging it in to this surface area, this new one. So if 1/4 is my a, then my a squared will be 1/4 squared. And 1/4 squared, if you throw it in your calculator, just multiply it, you should get 1/16. So now I'm going to multiply this new value to my scale factor to find out what my new scale factor will be. So 736 inches squared, I'm going to multiply that by 1/16. My new scale factor ratio. Okay, and if you plug this into your calculator, you should get 46 inches squared, which makes sense, right? So if you're turning a figure and you're making it 1/4 of the size, that means you're shrinking it, okay, then the new surface area should be smaller than the old surface area. All right, guys, so the question is, how many times bigger is the volume of a cylinder if the height is doubled? So I'm going to underline important things. How many times bigger is the volume of the cylinder if the height, only the height, is doubled? So unlike my last example, where all the dimensions of the shape change. So if I were talking about a cylinder, that means the radius of the cylinder changed and the height of the cylinder changed. That means every single part of that same shape changed in size by the same rate. But in this case, only the height of the cylinder is changing. So we want something that has to do with the volume of a cylinder and has a height in there. So I can just use the formula for the volume of a cylinder. If you remember, the volume of a cylinder is pi times the radius squared times the height. So notice only the height's changing and not the radius. So we have to kind of figure out how to solve this because it won't have the same pattern as my last example. So if the scale factor of the height is 2, right, we're doubling it, the surface area won't be 2 squared and the volume won't be 2 cubed. So because it's only the height that's changing, not the radius. If they were both changing, then it would have that pattern, but it's not the case. We're just going to plug in, compare the ratios. If my ratio was 2 to 1, okay, that means my dimensions of one height is going to be double the dimensions of another height. But the radius is going to stay exactly the same. So I'm going to pretend, just in a simple form, I'm going to pretend that the radius is 1, okay? and that the height is 1. Okay, just to kind of figure out an example. So I'm going to plug that into my formula. Volume equals pi times the radius, which is 1 squared, times the height, which is 1. So 1 squared is 1, times 1 is also 1. So the volume is just equal to pi. Okay, if we did have a cylinder that had a radius of 1 and a height of 1. So now I'm going to try doubling the height. So the radius is still 1 because that doesn't change. It's only the height that's being doubled. And the height, we're doubling it. So that's going to equal 2. So now if I plug it into my formula, I get the volume equals pi times 1 squared times 2, because now 2 is the height. So 1 squared is 1 times 2 is 2. Okay, so 2 times pi is equal to 2 pi. So this is my new volume. One of the volume of the cylinder with the height doubled is 2 pi, and the volume of the cylinder with just a regular height is pi. That's just the relationship, the ratio between the two. So I'm going to put them in ratio form, okay? 2 pi over 1 pi as a fraction. Okay, if I simplify this, first of all, pi over pi gets canceled out. So I'm left with 2 over 1, which is the same as 2. So this means that the volume of the first cylinder will be half the volume of the cylinder that's doubled, that has the doubled height. Or in other words, the cylinder with the height that's twice as big is going to be 2 times bigger than the original cylinder. So the answer is 2 times larger. So we kind of just have to plug in values. The simplest values are 1, and then just write kind of our new ratio for a second value and just compare the two. So it doesn't matter which values you plug in, just the easiest ones are 1, as long as you're consistent. Then that should give you the correct ratio. I would plug in 1 for everything the first time, and then compare it to your new ratio with the height doubled or the radius doubled or whatever the problem tells you to do.